In the title continuous random variable, we are going to solve problem number 2. The problem is if p of x equal to x into e power minus x square by 2 when x greater than or equal to 0 and it is 0 when x less than 0. Question part A is show that p of x is a PDF of a continuous random variable x, and question B is find its distribution function capital F of x. First part is we have to prove the given function p of x is a PDF. To prove it is a PDF, we should check whether the two conditions are satisfied. Condition 1 is p of x should be greater than or equal to 0 for all x, and condition 2 is integral p of x dx over the region Rx equal to 1. We know that e power minus x square by 2 is greater than or equal to 0 for all the values of x greater than or equal to 0. And if we multiply the term with x, again it is again greater than or equal to 0 for x values greater than or equal to 0. For less than 0 case, that is x less than 0, the function value is 0 already. P of x has that two intervals split up. So p of x is greater than or equal to 0 for all x. Condition 1 is satisfied. Now to check the condition 2, integral p of x dx is 1 or not. We are going to check it. So let us take integral p of x dx. Here the region real numbers minus infinity to infinity, and p of x is given as two cases. One is less than 0 case, that is minus infinity to 0 integral limits, and other part is x greater than or equal to 0, that is 0 to infinity case. So in this two part of the integrals, first part is obviously 0 because p of x is 0, and the second part is in our hand, it is integral 0 to infinity x e power minus x square by 2 dx. To integrate this integral, we should first uh, introduce some substitution, that is in the e power the term is x square by 2. Let us consider it as some variable u, and if we differentiate on both sides, we'll get 2x dx by 2 equal to du, and simplification will give you x dx equal to du. If we change some variable in integral, we should change the limits also. So if the values of x are 0 to infinity, then obviously u, variable u also takes the same limit because of the definition u equal to x square by 2. So x0 means u0, x infinity means u is infinity. Thus, we are in writing the total integral in terms of u including limits. That is integral 0 to infinity e power minus u du. If we integrate it, we will get e power minus u divided by minus 1 from 0 to infinity. Entering the upper limit will get 0, and for lower limit the value is 1, and denominator has already minus 1. So simplifying, we will get finally answer 1. So condition 2 is also satisfied. Thus we can conclude p of x is a PDF of a continuous random variable. A part is over. Now come to the B part. It is to find the distribution function capital F of x. Actually, p of x is divided into two cases. One is less than x less than 0 case, the function value is 0, and x greater than or equal to 0, the function value p of x is x into e power minus x square by 2. Now, before proceeding to capital F of x, we should recap the definition of capital F of x, that is cumulative distribution function or simply distribution function. The definition is p of x less than or equal to small x. That means up to the point x we should find the probability. Here it is continuous random variable, therefore we should integrate integral 0 to x p of x dx. For two cases we have to find capital F of x. First one is when x less than 0, f of x is obviously 0. And when x greater than or equal to 0, as per definition capital F of x equal to integral 0 to x p of x dx. So we write it integral 0 to x into e power minus x square by 2 into dx. And as per previous substitution procedure, we can enter the variable u as x square by 2 and the relevant terms. Finally, we are getting the term e per minus u by minus 1 for the equivalent of this integral. The limit is here, lower limit is 0 and upper limit is x. That means we have to enter x instead x. Limit itself is x, therefore there is no change in the term. E per minus x square by 2 minus of minus 1 for lower limit case. So after simplification, we'll get the answer 1 minus e power minus x square by 2.